Today I would like to share with you one of my favorite website to learn graph algorithm interactively. The author is called Amit Patel, and he creates a very wonderful website on how to visualize graph searching algorithm. The first reason I want to recommend this tutorial is that after learning the materials, I have a more abstract sense on graphs, on its topological sense. For example, here is a graph illustrated by the author, and if I move here, it shows that there is nothing difference between this graph and this graph. So that's one example. Besides the abstract graphs, and he also illustrates the grids, more general and more common graphs like this one. Very beautiful and very intuitive. The second reason I want to nominate this tutorial website is that I kind of grasp the essential idea of the fluff field, let's say, and here's how it looks like. Yes, and this is the fluff field. And before this tutorial, I never grasped the essence of the graph search algorithm. Okay, let me explain why this is essential and why this is so important.
So let's take a look on these three diagrams and why they are so important and so intuitive to help us to understand the three different kinds of graph search algorithm. Okay, so for the breadth-first search algorithm, the diagram is just circles. Actually, there's a reason for that. So let's see here. The distance between each circle is the same. So the offset of each circle is the same. Why is that? Because we are using the queue, and this queue it doesn't have any selection or filtering in it. It just loop each node from the neighbors. So for nests in the graph's neighbors, so they don't have any priority or kind of things. So that's the reasons why the distance of the offsets are the same. Now let's look at the Dijkstra algorithm. So as you can see, the shape of the circle is a little bit stretched. So you see from here the distance of the offset is quite big. But in here, it's like a steep slope here. So why is that? Because it is using the priority queue in this, let's say, the appending the candidates to the queue. In the last one, we have the A star. As you can see, there is a trend looping from here, and that's the key of the A star. The difference between A star and the Dijkstra algorithm is that besides using the priority queue, it also has a function called this one, heuristic. So these functions affect how the graph expands. So it's expand from here by experience. So that's the three algorithms illustrated by these three diagrams. And they are very important and very intuitive for us to understand the essence of these three.
Why does fluff field is that important? Because fluff field is expanded by this called frontier. Normally we use the queue or priority queue to select and push the candidate in the frontier. And the reasons behind that is that all these three algorithms is just a matter of how the frontier are calculated or how the frontier is expanded. So this is a breadth search versus Dijkstra algorithms. And as you can see, the frontier and let's say the fluff field is expanding in a very different ways. And the left one is expanding in a unique distance, I would say. And the right one is expanded like dodge around the forest on this side. And here's also another one is that the greedy best first search versus the Dijkstra algorithm and how they are compared. And for the right hand side, greedy best first search, it aims for the target and just go direct all the way out. And Dijkstra algorithms is not the same. So the authors gives a very intuitive and well explained diagram here compared these three algorithms, and the right hand side A star is just the Dijkstra algorithm plus the greedy best first search algorithm. The third reasons I would like to recommend this tutorial is that the authors implement the three algorithms into three different languages. All these three languages are very popular. The first one is Python, and the second one is C++, and C#, and is the third. So that said, from the previous blog, the authors focus more on the tutorial and on the educational part. And on this blog, on this article, the authors strengthens his efforts on the, let's say, the production code. So that's very nice. You can also find an answer from the very common pitfall using the graph search algorithm. For example, these ugly paths I see very common, like this is the pretty path, this is pretty path, but in the middle these are ugly paths, but all of these paths, they have the same weight and same distance. So ideally, the first and the last one would be the pretty one. Yes. Alright, to wrap up, if there is one thing for you to take over from my recommendation, that is the most intuitive material I have ever seen. So let's rewatch again. The fluff view. All these three algorithms is just the method how the frontier expand.